So here's the stop rail. I've got it on the bench now on its own, and as we saw from earlier in the video, we've got these three circuit boards. So there's one here, that's the second one, and that's the third one, and each one deals with the different divisions. So we have got the pedal division on this end, just here. The centre one is the swell, and then we've got the grate, and then on the end of the grate we have got if I can make it stay on the bench, we've got the reverb, the transpose control, reverb control, and then these LEDs here, which correspond to the position of the crescendo pedal. At least I think that's what they do. And then we've got this slider here, which is just a level control for the grate, and there's one of those also down here on the pedal division. So those are all part of these circuit boards on the back. So what I'm going to do is start with the biggest one, which is this one here. I'm going to remove all the screws so we can get this out of this large wooden stop rail, and then it'll be a bit more manageable. Get this onto the bench on its own, and we'll have a look and see how it works and how we're going to connect it to our new equipment. Okay, so we've got this board out of the stop rail now and it's on the bench on its own. I've taken this end stop rocker off. Obviously that sits on there. They just push on and they clip on with these little round onto the little round bar. But if I pop the M1 off, we can see what's underneath it and hopefully how everything works. So we'll put that out of the way. So we can see that in the middle, this is actually just a little, I suppose I think they used to call them festoon lamps or something that they used to put in cars, but it's basically, it looks like a fuse, like a glass fuse if I take it out. But hopefully you can see that. I don't know how close I can get this to the camera without it losing focus, but there we are. It's just a light bulb in the shape of a fuse, and it's marked around the cap here at 12 volts 1 watt. So that's what these are. So that sits in there, just clips in like that, and then either side we've got these little rubber push things, very similar to what we saw in the pedal board actually. So when you push one end of the rocker, it's got these things on, plastic things here. So obviously when you push one end in, if it's pivoted around the middle, then that pushes this plastic thing down, or rubber thing down, and that makes contact to pads on the board, if you like. And then if we turn this over and we look at this side of it, then we can see we've got 4 connections either side, and that's those little switches. The way they're wired inside is that the 2 either side are connected together, so that's connected to that and that's connected to that. Whilst it's obvious in this case it is, because there's a printed circuit board track between it, but on this side for example there isn't. But this is connected to this, and this is connected to this, and then when you press the button they connect the other way around. So this is not connected at the moment between these 2. When you press the button in, then that connects to that, and that's basically how the switches work. And then in the middle we've got these big solder blob connections here, and they are the metal end parts where this lamp plugs into. So it's pretty much that simple. So how are we going to connect this up? Well, first of all we need to work out how it's already connected up. You can see along the top here there are pairs of diodes, and there are 2 diodes for each rocker. So we've got 11 rockers, I believe, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there will be 22 diodes. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So that bears out our theory there. So obviously it's a diode matrix, but we need to work out exactly how they've wired that, so that we can use it in our or with our new product. So if we turn the thing over, we start tracing connections back. well, let's just start here. So these are where the diodes are along the top. So let's just take the first two diodes. So if we look on this side of the board, this is where they are. So one side of each diode is connected together for the first two, and then the other side, one goes to one side of this switch, and then the other one goes through. There's a jumper across there, and it goes to one side of the other switch. So one is on for the on position, and one's for the off position. So it's actually the one on this side is off, and the one this side is on. And the board is it's the right way up, but the main connections that were coming from the rest of the organ were at this side. So really it's more helpful if we flip the thing round and look at it like this, because this is the bit connecting to the rest of the organ if you want. And the reason I'm doing that is because that now makes this stop number 1 and 2, 3, 4, 5. So that's the way this matrix is going to be wired, so we can start counting, but we start counting from this end. So there's going to be diodes connected to one side of each switch, which there is. We've already proved that. We looked at the one at this end. And the other side of each switch is going to be connected to just a common rail. And there are usually, in a matrix, there are, well, say you had a 4x4 matrix, there would be 4 diodes that go to one common, and then you would start again with 4 diodes going to the next common. So let's see what we've got with this one, but we're starting from this end. So if we look at how these are connected, so that's this is the common side, because we said when you press the button that this connects to this. Okay, so they're not connected at the moment, but when you press the switch or the button, they are. So this side is our common side. So we've got this first switch is connected to this track here, then it connects to the next switch. Remember, they're connected internally between each other. So this then connects to that one, which then connects to here, that connects to the next one, that connects to the next one, that connects to that one, and that connects to that one, which gives us 1, 2, 3, 4, 5, 6, 7 switches on this first bus. And then, or we'll say bus, the first common line if you want. And then carrying on, we've got that connects to that, that connects to that, that connects to that, that's that. So we've got 4 on the next column, common. And this side's going to be the same. You could buzz it out with a meter or whatever, but it'll be the same. So that's pretty unusual, because we seem to have a 7 by something matrix. But actually, if you draw this out, which I've done, so I'll show you in a moment, what we've actually got is the diodes are paired in groups of 8, but the columns are only in 7s, which sounds super confusing, and I've no idea why they did it that way, and I've not seen it before, but that's what they've done. So let's have a look. It's easier to see when it's drawn out on a bit of paper. So this is what we've actually got with this diode matrix. So we've got column 1, column 2, so all of the ons, if you want. So row 1 goes to it's on, goes to column 1, it's off, goes to column 2, row 2 on to column 1, off to column 2, and so on, and that's up to row 7. And then row 8 we start on the new set of common lines or columns, if you're using the matrix terminology. So it's the same thing again, but what's interesting is there are actually 8 rows. So that means that the first row, if you want, the first 2 on and offs are connected to the first or the second 2 on and offs on the second column, or the second set of columns, which is just weird. I've not seen that. Anyway, that's what it is, so we're going to have to change that, and we'll do that in a little while. But what we're aiming for is this. So this is how our stop controller, which we're going to lighted stop controller, which we're going to use, this is how it needs to be wired to work with that. So we basically use 2 columns, and there are 16 rows for each column. The reason that it's done that way is that there are a whole bunch of these stop boards which seem to be used in a lot of organs, that are just wired this way, and it's easier if the controller matches what the commercial offerings are already, because then you can just plug things in. But unfortunately, in the case of this one, as we've just seen, it's rather strange. So we need to rewire these stops so that we have two columns, and each one of those columns has 16 diodes, so that's going to be 8 stops. So it's just going to work that row 1 is on, row 2 is off, row 3 is on, row 4 is off, and so on, and then that repeats again on column 2. I've taken this up to 12, but actually we're not using 12 because there are only 11 stops, so that ends there. So that's what we've got to rewire the thing to look like. So we'll get on and do that in a little while. I don't know whether I'll do that on camera because it's going to take a little bit of time. I might try and just record it and speed it up or something, but if not, I'll just leave that out because it's not very exciting to watch. So that's what we've got there. And the next part is how are we going to make these bulbs work, because these are 12 volt bulbs, 1 watt, and obviously our controller is fed by a microcontroller, so it's got 5 volt outputs designed for driving LEDs. Now we do have another board which we supply, which is a specific incandescent lamp driver, but actually looking at the way this thing is made, I don't think we're going to need to use that, because along the bottom here and up the side here we just happen to have 11 transistors, and that's 1 per lighted rocker. And if we look at how this is connected, let's flip this over again. Basically we have one side of all of those lamps is connected to these 3 pins here on this socket, and then the other side of the lamp comes through to here. If we flip the board over, we see that there's a resistor there. That's, oops, if I get it in camera, that comes through to this resistor, which is a 15 ohm resistor, and then the other side of that resistor comes down to this transistor here. So the other side of that resistor comes down to this transistor. The base of the transistor goes across to this whatever that is, 4.7k resistor, and the emitter of that transistor goes to earth, or 0 volts. So this big part of the circuit board here, that's 0 volts, and that comes up to these 3 connections on that plug as well. So the resistors are for the base. There's 1 for each transistor, and then for these 3 over here as well. There they are. Yep, so those are the base resistors, and these are the 15 ohm resistors going to all of the lamps. And the base resistors come and connect into this chip here, which is an 8-stage shift register. So that would make sense that they're using that just to drive these transistors, and the output drive from this chip is going to be somewhere around 5 volts. So that's jolly handy, because it means that we can connect our LED outputs from our stop controller directly to these resistors if you want. We'll need to take this chip out of circuit, so we'll remove that, and the reason we need to do that is because if you put power on one output, the chip's not going to like that at all, especially if the rest of it's not connected, it's not got a power supply. So you're going to end up with putting power on one output, and it's probably going to come out another one and do all sorts of bad things that we don't want. So actually I believe one of these is faulty anyway, because one of the complaints the customer had before this organ died completely was that all of the stops used to light up at once. So that's, if they do, then that's down to this chip being faulty anyway. So what I might do, just to prove what we're saying and make sure that we're along the right track in a minute, is to actually wire this up with 12 volts on it, and then we'll apply 5 volts to these different resistors and just make sure that the lights work in each of the stops. At least it proves the bulbs, and it proves that we've reverse engineered, if that's the right term, the thing correctly, and that we're along the right lines. Now that takes care of the stops. The other bits and pieces that we need to worry about on this board are the transposer switch, these LEDs here, which are for the crescendo pedal. They show which level of crescendo you're at if you want. The two sliders will be used, so this one was for reverb and this one was for what was this one for? This was just the level, I think, sound level of this particular division, and this, I'm not sure what that was for, but we'll wire it up anyway. Now if we look at these sliders and we trace the wires back, or the tracks back, they all come to this connector here. So that's quite handy really. It means that we can just connect to these. We don't have to worry about soldering onto the back of the sliders themselves or anything like that. So when we come to connecting those, we'll just use this socket here, and we can just trace them along. Literally just by looking at them you can see where they go to. So that's what we'll do with those. The LEDs, they've all got series resistors, which we don't need because our controller has those resistors built in. So probably what I'll do is just remove these resistors, and then we'll run wires from where these resistors were connected across to our controller board. So that makes that nice and easy. And then this transposer switch, again, that comes into a bunch of diodes here. So almost certainly this is going to be another matrix. 1, 2, 3, 4, 7. Yeah, I'd say that's going to be another matrix. And there'll be a common there. How many positions is it? 1, 2, 3, 4, 5, 6. 6 positions. So yeah, that's going to be a matrix. We can deal with that, and I'll show you how we do that when we get to that a bit later on. So that's really what we're going to do. So what I'm going to do next, I'm going to remove this chip, and actually I'm not. Before I remove it, I'm going to connect some power up to this thing and see what happens when we try and power the lamp with these. I'm expecting them all to come on at once, simply because the customer said that's what they do, and then we'll take this chip out, we'll remove this, and we'll see that hopefully once we have, then they're all independently operated by putting control voltages on these resistors. So that's what we do next. Okay, so I've connected 12 volts to the board here, to those positions on the plug. So as we said, so one side of the 12 volts goes to one side of all of these lamps, and the 0 volts or ground comes to the emitter of all of these transistors. So on this other lead here, I've got a 5 volt supply. So there's 12 volts on these and 5 volts on this one. So the plan is that when I touch the 5 volts to any of these resistors connected to the base, the respective stops should light up. So if I put 5 volts on the first one, as you can see, all the stops come on at once. And that was one of the complaints of the problem of the thing in the first place, before it died completely. So almost certainly that's going to be down to this chip. So what I'm going to do now is I'm going to remove this chip, and then we'll try that same experiment a second time. Okay, so I've got the desoldering gun warmed up now, so let's just turn this over and desolder this. Right, so that's desoldered. We'll just pop this out now, like that. Turn off the desoldering gun because it's quite noisy, and let's try that experiment a second time. So we'll reconnect our 12 volts. Okay, and switch that on, and we'll take our 5 volts, and now hopefully you can see that they work independently as they should, and those last three are come over here. Which way round is that resistors connected? Hold on. Okay, so the base goes to this side, so we're going to put our 5 volts this side. So we've got the same problem here. These connect to that chip probably, because it's the same one as the last one. So let's turn on the desoldering gun again, and we'll pop this chip out, and then that'll solve that problem there. So remove our 12 volts. So let's remove that, turn the gun off, put our 12 volts back on. Those. Okay, so now if we connect to these, as you can see, well, hopefully you can see the light's actually quite severe, but there we are. I've got 2 at once there, but 1, 2, 3, and then the others just carry on down here as we did before. So that's all good, that all works. Whilst we're here, these other resistors here are connected to these LEDs, so in theory, assuming that the negative is connected through, which it isn't, so I was just going to test that anyway, see if they work, but the 0 volts or ground connection for these is not connected to the ground connection for the lamps on the board, so we'll worry about that later. But either way, these are the resistors for these LEDs. So what I'm going to do is just remove these resistors so that we can connect directly to the LEDs and across to our controller. So I'll pop those out now, and then I think we're about done with modifying this board in terms of removing things. All I've got to do then is just wire up the matrix as I explained previously, so that it matches our new controller. So that's what I've got to achieve. So once I've got these resistors off, I'll do that. Okay, so that's done, resistors removed, those 2 chips removed. So I think I will move on now to wiring this up in the matrix, and then we will, or in the correct matrix, and then we'll take a look at connecting it to our controller.